Complex and imaginary numbers. You have learned before that you cannot square root a negative number. For example, the square root of -1 cannot be done. There is no real solution to the problem of the square root of -1. So that means it does not correspond to a physical quantity that can be measured, such as a length or a weight or a speed. No real solution. Not a physical measurement. Or quantity. It doesn't represent time, weight, or speed. Also, the square root of -1 cannot be represented on a simple number line. The number line 0, 1, 2, 3, positive numbers, -1, -2, -3. Because the square root of -1 isn't a physical quantity, it can't be positioned anywhere on the positive and negative number line. We can say that the square root of -1 is equal to j. Mathematicians use square root of -1 is equal to I. This is the same thing, but j is used in engineering to avoid confusion with I for current. Square root -1 equals j introduces a new set of numbers, c, the set of complex numbers. Complex numbers have a real and an imaginary part and can be located on the complex plane. The complex plane is a coordinate grid with x being the real axis and y being the imaginary axis. The real axis is horizontal and vertical is the imaginary axis. Sometimes complex solutions are found when we solve quadratic equations. For example, x squared add 2x add 5. If we want to solve for x, we can't factorise, it does not factorise, but we can use the quadratic formula. (b plus minus square root b squared subtract 4ac all upon 2a. In our quadratic equation, a equals 1, b equals 2, and c equals 5. substituting these values, -2 plus minus 2 squared subtract 4 times 1 times 5, all upon 2 times 1. Simplifying, we have -2 plus minus square root of 4 subtract 20, -16, all upon 2. Before we continue to solve the quadratic equation, we look at what's inside the square root, -16. You wouldn't have been able to carry on from this point because -16 inside the square root has no real roots or no real solutions. This time we can use the square root of -1, j, in order to get a complex solution or two complex solutions. Changing -16 into the square root of -1 times 16, this means -1 multiplied by the square root of 16. Square root -1 equals j, square root of 16 is 4, so we can write j4. Now here the normal convention is to put the j first. And the number second. Carrying on solving our equation, we had x is equal to -2 plus minus square root -16 over 2. This is -2 plus minus j4. Replace the square root of -16 by j4 and divide that by 2. So x is -2 divided by 2 plus minus j4 over 2. I'm splitting it into two separate fractions to simplify. So x is -1 plus minus j2. Two solutions exist and they're both complex. A complex number has a real part and an imaginary part. And in general, a complex number is written as a plus jb. The first part, a, is the real part. And the second part, b, is the imaginary part. This is a complex number. This is called the rectangular or Cartesian form of a complex number. Following on from our solution to the quadratic equation, we had two solutions, -1 plus j2 and -1 subtract j2. So the real part in each of these is -1, and the imaginary part in each of these is either 2, j2, or -2, j2. Often, complex numbers can be represented with z. We can call solution 1 z1 and solution 2 z2. And these two roots can be drawn on the complex plane. There is another name for the complex plane, and that's an Argand diagram. The horizontal or x-axis is the real axis. You must label this with real or R, and the other one is the imaginary axis. You can write imaginary or J. Z1, -1 plus J2 can be drawn as a coordinate -1, 2. -1, 2 would be here, Z1. So it's in the second quadrant of the Argand diagram. Our other solution, Z2, -1 subtract G2, can be drawn as the coordinate -1, -2 on the Argand diagram in the third quadrant. Label these Z1 and Z2.